Welcome again. In this video, we're going to talk about stacks, a specific data structure that lets us store elements and access them one by one. So, starts follow a LIFO strategy, and LIFO means last in, first out. So the last element that we add to a stack becomes the top of the stack, and then that becomes the first element that gets taken out of the stack. Think of a stack of plates or a stack of papers that you work with on your desktop. We have four main operations, which are pushing an element to the stack, and the opposite, popping an element from the stack. We can always check what the top element of the stack is with the top method, and of course we have an isEmpty check to check whether the stack is empty. Of course, you should always check whether the stack is empty before applying either the top or the pop operations, or you might get an error. We have an implementation here of the stack using a list. So first we have our constructor up here. We create a class attribute called items, and we initialize it to an empty list. Notice how this attribute is private because we use the double underscore. We do not want the user to access this inner list, but only use the external methods, the public methods that we have defined. Of course, we've defined the four methods that we mentioned. Push is very easy. We just append the element to the list. Pop removes the element with the pop method of the list attribute. Top consults the last element and returns it. Of course, these two methods will fail if there are no elements in the list, because this operation will fail and this operation will fail. And finally, we have isEmpty that checks the number of elements in this underlying list to check if there are any elements in the stack. Let's see an example with some drawings. So we can first create a stack using the constructor. Then we can check whether it's empty, and it is. It says true. And then we can push a few elements onto the stack. You can see that each element gets added to the top of the stack. And when we print the stack, we find that the inner representation shows us A, B, and C, with C being the top, as we can see here explicitly. And whenever we want to remove the top element, we can use the pop operation, and we have to store the result because it returns the last element that was at the top of the stack. If we print that, we find that the top element was C, and now the stack has been altered such that it is now A and B, and the top is B. And that is all. I'll see you on the next video.